Hello everybody, I hope you're all doing well. Welcome back to question number 3 on the 2008 Hypatia contest. Hopefully you've downloaded a copy of the contest, tried this for yourself. Not going to lecture you guys about it at this point. Let's take a look and do some math. So we got 3 parts for question 3, A, B, and C. And we've got a diagram. In the diagram, ABCD is a trapezoid with AD parallel to BC and BC perpendicular to AB. Very nice. So that must mean that BA must also be perpendicular to AD. We might need to use that. We're told AD is 6, AB is 20, and BC down here is 30. Okay, so that's all the information we've got. If we want more things like angles, we're going to have to figure those out on our own. So, part A, determine the area of trapezoid ABCD. Okay, well, there's a nice little formula for the area of a trapezoid. If you haven't seen it before, you definitely should have, but if you haven't seen it before or need a little refresher, that's okay. For a trapezoid where we've got parallel sides, and the sides have lengths A and B, it doesn't really matter how the rest of this thing looks, and if we know the height, h, the area of the trapezoid is 1/2 A plus B times h. The way this formula works out is you take another copy of this trapezoid, rotate it 180 degrees, and staple it onto the end. And then you get a parallelogram with A plus B as its side length and h as its height. And so area of parallelogram is height times base, just like a rectangle. And then we divide by 2 because we copied the trapezoid. You don't need to show that, just in case you were wondering where does this formula come from. Okay, now fortunately, we know the lengths of the parallel sides, and we know the height. A, B, C, D, and we've got 6 up here. So, the height of the trapezoid, which is really the only thing I think we need to point out, is AB, and that's 20. So the area of ABCD is just 1/2 6 plus 30 times 20. So the 1/2 and the 20 will cancel out and give me 10. And then the 6 plus 30 is 36. So 360 is the area. And if you wanted to, of course, you could put a little therefore statement or just some statement to sum it up, but I think a box is fine here. They didn't give us any units like millimeters or inches or anything, so we don't need to include that. And you don't need to say something like units squared. They don't give you units, don't give them units. Okay, so we got B part. There is a point K on AB, so somewhere on this altitude here, such that the area of KBC, and that will be a right angle triangle, equals the area of quadrilateral KADC, so basically whatever's left over. Determine the length of BK. Alright, well, we'll draw a little picture to make things clearer, but I don't anticipate this giving us too much trouble. There we go. A, B, C, D here. We've got 6, 30. And then we've got this point K, which we will put in green. So K is somewhere around here. And so we've got the remaining quadrilateral KADC, that's this half. And then we've got KBC, which is this part. And we want, KBC and KADC make up the whole area of ABCD. So if we have KBC equal to the area of KADC, then area of KBC If both of these are equal, then this line KC splits the trapezoid in half. So KBC, that triangle must have half of the area of the total quadrilateral, or the total trapezoid. So it's going to be half of 360. So it's 180. So that's what we want. Okay. Now, that's what we want to have happen. That's not what we need to calculate. What we need to calculate, they want the length KB here. Okay. But that happens to be the height of our triangle. KB is height of our right-angled triangle KBC. You don't really need to mention that it's right-angled. I would say it's clear as long as you draw the picture with the little right-angle symbol. But if you want to, point out KB is the height. And the base is BC, which we know is 30. So we want 180 is 1/2 base times our height, which is KB. So it's going to be 1/2 30 times KB. So that's 15 times KB. And we're going to have to flip over to the other side, but 180 equals 15 KB. We see KB is going to have to be equal to 12. 12 is 180 over 15. Okay. Well, that actually wraps B up. We've got we finished the calculation. And maybe a sentence or two explaining would be fine if you are someone who really likes sentences connecting what you're doing. But all our work is there. We point out KBC, KADC splits the whole area in half. That's what makes our work from A useful. You might even want to add, we know it's 360 from part A. If you want to add that, that's fine. It shows the connection. The work we did in A is paying off here in B. So KBC has to have area of 1/2 of ABCD. So that tells us it's 180. We know the base. The length that we want happens to be the height. We're all set. Okay. So our answer is going to be 12. Nothing else to say about B here. C part. There is a point M on DC, which is this line over here, such that the area of MBC, so we're again connecting it up with the B and C, equals the area of quadrilateral, the rest of the stuff, MBAD. Determine the length of MC. Okay. Well, it's basically the same setup. It just it's going to be a little harder because M lies on a line that we're not particularly familiar with. So we got 30 down here. We've got A, B, C, D. 6 we might need. 20 we might need. And what's a good color? I don't use brown very often. So M is somewhere on here. And we've got MBC plus MBAD is the whole area. The whole. So the area of ABC, the area of that trapezoid, is the area of MBC plus the area of MBAD. Okay? But we want area of MBC to be equal to the area of MBAD. So, plugging that into our equation, the area of ABCD is twice the area of MBC. So, just like in part B, area of MBC is 1/2 area of ABCD, which we know from A is 360. So it's once again going to be 180. Alright. Well, we have the same base. This is going to have the same height here. We'll use the funky blue. This is very much the question of me messing around with the colors on my color pad. But we're going to have some height here. I don't know, M, let's call this point N. So we'll drop altitude Mn to BC. Then 180 is 1/2 BC times Mn, which is 1/2 30 times Mn, and just like in the last one, Mn is going to have to be equal to 12. Okay, so we now know this length here. It's 12, but we don't want that. We want MC. That's what they asked us for. Determine the length of MC. So we're not done. This 12 here, it could help us, but we're not finished. Okay, what can we do with this 12? Well, let's redraw the picture. So what did we have? So M is here, and we get this altitude, and it's 12. And we want MC. Okay, what can we do? Well, notice that we've got some right angles. We don't quite have a right angle up here at D, nor do we have a right angle down here at C. But we dropped an altitude to N. What if we draw another length using, I don't know, this color here, this peachy color? Okay, and we might call this point E. Let's say something like draw DE perpendicular to BC. Well, then we see, so we got a 6 up here, we got a 20 here, we have a 30 down here in total. We see that ABED is a rectangle. So BE is 6, DE is 20. Where am I going with this? I'm going to get two similar right angle triangles. But I know 20 is here, I know 6 is here. What's left for EC? Well, we can calculate that out. So EC is BE plus EC. This is 30, 6, and then what is EC? Well, we rearrange. EC is 24. So we got 24 here. Okay. So 20, 24, but this is similar. This is similar because we've got this angle, they're olive green, and we got this angle right here and two common right angles. So I'll say since they share angle at C and are right angled, we see triangle DEC is similar to triangle MNC. And since they're similar triangles, we can say the ratio of MN over DE is the same, because those are the parallel lengths, is the same as NC, which is something we don't know, over EC. So we got 12 over 20 is equal to NC over 24. So I'll do some multiplying here. Divide by 4, and we'll get 3 out of 5 is NC over 24. So 72 over 5 is NC. All right, not the nicest of fractions, but we can work with that. And now MC squared, so by Pythagoras we could even say, MC squared is MN squared plus NC squared, and that's 12 squared plus 72 over 5 squared. And that's going to be 144. If I multiply that by 5, I will get 720 over 5 plus, and then 72 squared. I really don't want to use my calculator, so we'll just multiply it out by hand. 4, I think it's 2804. No, that'd be way too small. 1, 4, 0, 4, carry the 1, 5, 0. So 4, 8, 1, 5, 5. So 5, 1, 8, 4 over 5. We'll hide our work. And add those two together. We'll get 5. So it'll be 4. And then the 2 and the 8 will be a 0. Carry the 1, so it'll be 9. So 5904. I don't believe that's a square. Oh, this should be over 25. Okay. So that'll be 3600 over 25. And we'll add these again. The 8, 4 will stay at the end. The 6 and the 1 will be a 7, and then 8. I'm pretty sure that's not a square. And if we square root this, we should get our answer. We'll flip the page, and I think I'm going to have to use my calculator, which I really didn't want to. 8784. They are allowed. I just try and avoid using them when I can. Test my mental arithmetic. Yeah, nothing special there. We can divide 8784 by 4. And by 4 again. So it looks like it's 4 root 549 over 5. That's divisible by 9. So it'll be 61. So 12 root 61 over 5. That seems oddly inelegant, but there we go. I want to go back and double check my work. So got all the numbers correct there. We are asked for MC. At the same point, it'll be the same 12. Got 20, that's fine. 12, that's fine. 24 here. And then NC, yeah, I guess it's 3 to 5, so it's 3 to 5 here. Just that's 6, bringing it down to 24. Just made it all sort of messy. But there we go. MC is 12 root 61 over 5. 20 squared plus 24 squared is 976. And yeah, that's 16 times 61, so multiply that by 3 over 4 and you'll get, yeah, okay. I don't usually expect an answer like this. A root 61, sure. 12 root 61, sure. But 12 root 61 over 5, then I start to think I've done something wrong. Turns out I haven't. But when you get those instincts, and if you practice a lot, you will start getting those instincts, then it's always good to go back and check. Okay? Don't spend too much time checking because you are good mathematicians. And you want to leave time for question number 4, which is what we're going to do in the next video. So feel free, if you would like to like, subscribe, leave a comment, anything like that. And I will see you guys for question number 4 as we finish off the 2008 Hypatia in the next video.